Normal distributions. So take a minute to read over this helpful information over normal distributions. And I encourage you to pause this video. This next page here has a hit image and some helpful information about a normal bell-shaped graph. So if you notice, this right here is the negative values to the positive values, and this is talking about our z-table, right? And this is my mu minus 3 standard deviations. So whenever we're talking about the 3 standard deviation, well, you know, we got 99.7%. This one here is mu minus 2 standard deviations, and we have the negative and positive. So if you notice, we have the minus, we also have the plus over here, right? So these 2 standard deviation gives us a 95.4%. And then when we have the 1 standard deviation, we get 68.3%. And if you notice, mu falls right here in the middle and it's split in half. And mu is the highest point, which is causing this normal bell shape. Okay, so underneath it is some more graphs, and I thought it was a great example of showing you the difference. So if we have a standard deviation of 1, these values, the data set is closer to the mu, so it's tighter, but we still have a bell shape. The further away we go on the standard deviation, you notice that the data sets start falling away and we start getting more of a tail on the sides. But we still have the bell-shaped curve because the mu, the mean here, still the highest point of this data set. So let's do example 1. Example 1 is telling us to use the z-table to determine and indicate these values. We're going to find the area under the standard normal curve from 0 to 1.8. So I'm going to pull up the z-table. And we want to find where z is equal to 1.8. What we're going to do is come down here and start underneath the z and go all the way down to 1.1. And then we're going to go across to where we find 0.08. And here we go. We have it 0.3. Here we go. So the area here is going to be 0.3810. Okay. So on the second one, it says do the same thing. We're finding the area under the standard normal curve, except for this time it gave us 0 to negative 1.38. And you notice the z-table doesn't have negative values. So what we're going to do is find the absolute value of this. And what we know when we take the absolute value, it ends up being positive. So we're going to go back to that z-table. We're going to go down to 1.3. And as you notice, it's already circled here. And then we're going to go across to 0.08. And we get 4162. So the area is 0.4162. Okay, so now let's do our next one. Our next example, we're going to use this formula here that's given to you at the above. It's called the distance between a measurement x and the mean u in standard deviations. So example 3 says, given a normal distribution mean of 100, a standard deviation of 10, find the number of standard deviations the measurement is from the mean. So we're going to answer as a positive number, and this is my x. So let's plug it in. I got 108 minus 100 divided by 10, which gives me 8 divided by 10, which is 0.8. So that is the answer. So example 4, we're going to use that formula again. Given a normal distribution, mean of 100, standard deviation of 10, find the number of standard deviations the measurement is from the mean. Express the answer as a positive number, 60. So that's my x. So let's plug it in. Okay, so now I got 60 minus 100, I got negative 40 divided by 10 gives me a negative 4. And that is our answer. Okay, number 5. Given a normal distribution mean 100, standard deviation 10, find the area under the normal curve from the mean to 129.8. So we will end up using the z-table for this, but first we got to figure out what c is in order to do that. We're going to use that formula that we just got there using. So we got 100, and note 129.8 is going to be my x value. So 129.8 minus 100 is 29.8 divided by 10. We get 2.98. So we're going to take this number and go to the z-table. And when we go to the z-table, we're going to go down 2.9. And then we're going to go across to 0.08, and we will get our value. And the area for this is 0.4986. So a sentence statement, we'll just write one right quick. Therefore, the area under the normal curve from the mean (100 to 129.8) is 0.4986. Okay, so let's do example 6. It says, given a normal distribution mean of 35, standard deviation of 5, find the area under the normal curve mean. So we're going to do the same thing here. Okay, so now we get 2.5. It's negative over 5. And this gives me a negative 0.5. And normally when we're at 0.5, we don't put 0 behind it, but when we're going to the z-table, we need to know what's behind that 5. And of course, if you don't write nothing there, we know it's 0. So when we go to the table, we're going to look for the positive. Remember, it only has positive value, not negative value. So the answer is negative 0.5 here. However, we have to take the absolute value of this. So we're going to go to the table, go down to 0.5 and over to 0.00, and you'll find the value. And the area, once we do this, we notice that the area is 0.1915. And if we write it in sentence form to make our statement, we're going to say, therefore, the area under the normal curve from the mean 35 to 32.5 is 0.1915. Okay, so let's do our next example. We're going to consider the normal distribution with the mean 60 and standard deviation 5, and find the area under the normal curve above the interval. So we're going to find the area under the normal curve and above the interval of 50 to 65. So here we go. We know our x values. We're giving 2 types of x values. So we're going to have 2 areas to find here. And it says on a horizontal axis as well. All right, so what I need to do is find Z1, right? So I'm going to plug in what I know. What I know is my first x is going to be 50 minus that 60 divided by 5, which gives me negative 10 divided by 5, which is negative 2. So when we go to the z-table, remember, we need to look at the absolute value of that, which is positive 2. And when we go to the z-table, we'll notice that the area at 2, so we go down to 2, cross 0, 0.00. We get an area of 0.4772. Now let's find the second one. The second one is 65 minus that 60 over 5, which gives me 5 over 5, which is 1. And so we're going to go to the Z table and find the area of that one. And the area of that one is going to be 0.3413. Okay, so now we're going to give the answer of the total area for it. So we're going to take A1 plus A2. So I have 0.4772 plus 0.3413 gives me 0.8185. And that is our answer. Okay, so let's take a minute and do example 8. Example 8 says consider the normal distribution with a mean 75, a standard deviation of 6. And now we're giving an interval for x here, 84 to infinity. So infinity is not an exact value that you can find. So we're going to have to do a little bit extra work here. So first things first, let's find our Z1. So we're going to take the 84 minus the 75 divided by 6. And when we do this, we get 1.5. So you're going to go to the Z table, go down to 1.5 and across to 0.00. And that area gives me 0.4332. Now that I've found that, I'm going to use this information to find the area 2. All right, so to find the area 2, we're going to take half minus the area 1. So now we get 0.0668. And when we state this now, the area under the normal curve for this interval, 84 to infinity or larger, it's going to be the 0.0668 because we are talking about going off to infinity. So this is what we're going to have. Okay, so that includes all the values. It goes small all the way up to the largest point, just keeps on going. And whenever we talk about a normal distribution, we do talk about a bell-shaped curve. With that means the mean is in the middle. And then we have some values, negative values and positive values, right, on either side. This and this adds up to 1 or adds up to 2 or adds up to 3, depending on what the standard deviation is. So that means if I am factoring the area, I'm factoring the area for one side, then I factored the area for the other side. So if we're looking for its missing piece, this is where we took half of it because we knew that we was considering half of the area in one calculation. Okay, so let's do number 9. Number 9 says that salespeople for a solar technical or technology company have average annual sales of 500,000 with a standard deviation of 20,000. What percentage of the salespeople would be expected to make annual sales of 540,000 or more? Assume a normal distribution. So what we're going to have to do here first is we need to let's mark what everything is right quick, and let's go from there. We have this as my x. This is my mu. Oops, I said mu, which is correct. I just wrote mu, and this is my standard deviation. So first, let's find the z. So I got 540,000 minus 500,000 divided by the 20,000. So now I got 40,000 divided by 20,000, which reduces to 2. So now I know what my Z is, and I can go to the Z table to find the area for this. And when I go to the Z table, find the area, I get 0.4772. So now let's move on to the next part. We want to find the second area of this in order to come out with our answer. So I know that my second area is going to give me half minus my first area. And when I subtract these two, I get 0.0228. So that would tell me my second area. Now we're going to multiply by 100 to find the percentage. Okay, because that's what it asks for. It asks for the percentage. So I'm going to multiply by 100%, which gives me 2.28%. And now I'm going to write my sentence. 2.28% of the salespeople, I believe there's an S here, can be expected to make annual sales of 500,000 or more. Okay, so let's do our next one. It says a manufacturing process produces a critical part of average length 70 milliliters with a standard deviation of 4 milliliters. All parts deviating by more than 5 milliliters from the mean must be rejected. What percentage of the parts must be rejected on average? So we got our mean, we got our standard deviation, and we have our X. So first things first, let's find Z. So my Z is going to be the first value. We're going to have to take the 70 because we got it's deviating from 5, right? That's what it said, deviating from 5. So I need to take that 70 and subtract the 5. And it's going to give me when X is less than or equal to, right? The 65. And then we're going to take 70 and add the 5. Because remember, whenever we're talking about a normal distribution, we're talking about both sides, a negative and positive value of both sides of the mean. So this tells me X is greater than or equal to 75. So we're going to take these values. I'm going to start off with the 65, subtract it from the 70, all divided by 4. So I get 5 divided by, it's negative 5 divided by 4 gives me a negative 1.25. Now, when you go to the Z table to find this one here, this area, we know that we have to take the positive of it, right? We have to take the absolute value to get the Z. So we'll go down 1.2 to the right, 0.05. We find that the area here is going to be 0.3944. Okay, so now let's find the area for the second. So we're going to take 1 minus that area. So it says 1 minus 2 times this area. So we are talking about 2 particular points because it says deviating by 5 or more. So we calculated 2 points, right, on both sides. So I'm going to multiply it by 2. We are talking about the whole area under this curve. So now we have 0.2112 and multiply it by 100%. This is going to give me to 21.12%. So my sentence here is must be rejected. On average.